You're welcome to this lesson. In this video, we're going to consider two intersecting cylinders with unequal diameters. So we are expected to draw the given view, which is on the left hand side. With the given dimensions, we are going to start. We draw the horizontal line. Now the diameter of this cylinder F is 50 millimeters. So we'll draw the horizontal line, get the midpoint. The radius of our compass is 25, and we'll mark to these 2 points. Then the height is 80 millimeters. So at this point, we'll describe the point here, then draw the horizontal line to meet the other point here. Then we erase unwanted lines. So this is the first part. Then we'll go to the base, which is the distance 10 millimeters from the base. So that we'll get the angle 45 degrees for the second cylinder M. So at this point, we project the line. The distance from the point here is 65 millimeters. So we'll mark that point. So to get this, we'll get the 45 degrees to the horizontal, which is 90 degrees to this line, so that we can get this point. Then the diameter here is 35 millimeters. So we'll get the length and describe it this way. Now from this point, we'll draw the line to meet the cylinder F. Now I've gotten the major outline for our cylinder. We now mark the midpoint for the cylinder M and project the midpoint, the midline, this way. After having this, we're going to get the plan. So mark this point on the central line, then describe the circle. Then we'll draw this line. Then from the front elevation, we can be able to get from the front elevation, we'll be able to get the required view of the plan, the face of the cylinder M on the plan. So we are going to draw this semicircle, then extend the line. Since the two centers are not the same, as in the center for the cylinder M and the center for the cylinder F, they are not at the same point. So we're going to draw it this way. So after having this outline for the plan, we're going to, so at this point, we'll divide the semicircle into 6 equal parts using the 30 degrees and 30 by 60 degrees set square to divide it, so which will give us the required angle at this point. So after dividing it, we'll label it 0, 1, 2, 3, so that we'll get the required view. So now for this cylinder M, in the front elevation, we're also going to divide it into 6 equal parts. Now since it's at the angle of 45, we'll make use of 45 degrees set square and 30 degrees set square to give us the required divisions. So after dividing into 6 equal parts, we'll also label it 0, 1, 2, 3. Now since there's a 90 degrees change in phase, the labeling is going to be different from that of the plan, since the change in phase is 90 degrees. So now we're going to project the lines from each of those points. We'll radiate the lines. Now where those lines meet will give us the required locus of the phase from the plan. So here we radiate the lines to meet each other from the front elevation to the plan. So where they meet, that's 0 in the front elevation to 0 in the plan, then from 1 to 1, like that. We mark each of those points, and after doing that we'll connect them using the required tool, which is French curve or the flexible curve. Then we'll have this ellipse, which is the top view of the face of the cylinder M. So now we're going to radiate the line. Now this is the 3D view of the two cylinders. This will help us to get the curve of intersection, which is not like the common way we have our regular curve of intersection, since the centers are not the same. So that's why I had to create it, the view like this. So start from the where the 3 and 3 meet, the 2 and 2. Then here we have the 0, that's the maximum point. Then we'll connect other ones respectively. So take note of this view. So as you can see, this side, the curve here is different from this one being seen. Now due to the software I'm using, I can't get the apex to get a perfect curve there, so it's looking as if it is pointed. So however, when drawing with paper and pencil to give us the required curve. Now we're going to create the development of the cylinder M along the seam X, which is the top side of it. So now we're going to, since we've divided the face of the cylinder into 12 equal parts, this is the semicircle, which is 6. So now we can get from the 6, we can get the 12. So either we, from the whole length, we can get this, or pick each of the distance, either 0 to 1, 1 to 2, or 2 to 3, to create this line, or you get the whole circumference and divide it into 12 equal parts. Now the distance from the base of the cylinder to where it meets, join the, now radiating from the second point, now from this point to where it touches the cylinder F, we'll transfer the length. So we'll do that for each of the points and describe it on this lines. Then we'll get the development of each of the lines. So now after having this one, we'll repeat the same process for the remaining half, which is the second phase. So now that we're done with this, we'll use our French curve to connect each one of them, each of those points, to get the required curve. Now connect it, and this is the development of the cylinder M along the seam XX. Alright, this is the whole questions, answer to the questions. Thank you for watching this video. Ensure to subscribe to this channel for more videos.